Hi everybody. Today I'm going to be going over Chapter 4, Question 14 from the bingo questions. So, Question 14 gives a velocity versus time graph, and it talks about this cat that's moving in a straight line, and we're dealing with its x-coordinate as it's traveling. And so this is a graph that represents the movement of this cat. And part A wants us to find the maximum net force on the cat. Part B wants us to find when that net force equals 0. And part C wants to know the net force at a specific time, which is 8.5 seconds. So if you've seen my video on question 13, we deal with an acceleration versus time graph. And so if you're interested to see how force works with an acceleration versus time graph, go check out that video. This one is a velocity versus time graph. So we do it a little differently, but the information can still be found from the velocity versus time graph. So part A wants to know the maximum net force on the cat. And so, as we know, that force equals mass times acceleration. And so we want to know, and in the problem it gives us the mass of the cat, which is 2.75 kilograms. So what we're really looking for is the change in acceleration, because the mass of the cat is not changing within this scenario here. And so the only thing that changes is that acceleration. So since we're given a velocity versus time graph, we'll need to find when the slope of the graph is the greatest. Because if you remember, the slope of the graph of a velocity versus time graph is the acceleration. Because the acceleration is the change in velocity over time. And so if we look at this graph, we can tell that the steepest slope is right here, from time equals 0 to time equals 2 seconds. And if we do the math, rise over run, we know that the slope here, so we'll just say, we're going to use m for mass, so we'll just say s for slope equals 4 right here. And so that means that the acceleration at that time is 4 meters per second squared. So now what we do to find that max net force is we plug in what we know into this equation, and we get force equals 2.75 kilograms times 4. And when we do that out, we end up getting the maximum net force to equal 11 newtons. And remember that maximum net force is happening from time equals 0 to time equals 2 seconds. So that's it for part 1. We found the maximum net force on the cat. Now, let's look at question 2. So now it wants to know when the net force equals 0. So once again, the mass isn't changing, right? Mass is the same in this problem. So we need to look at when the acceleration is 0. And with a velocity versus time graph, we know that the acceleration is 0 when there's no slope, when the slope equals 0. And so we can see that right here, from time equals 2 to time equals 6 seconds, that the slope is 0, which means the acceleration is 0. I'll just put that there to remind you guys. So we know that from time 2 to time 6, so 2 to 6 seconds, we know that that cat is not accelerating. It has a constant velocity. And that means that the net force is going to be 0, because if we plug it in just to see, F equals 2.75 times 0 equals 0. So the answer to part B is that it equals 0 from t equals 2 seconds to t equals 6 seconds. And that's it for part B. So now all we have left is part C. And it wants to know the net force at time equals 8.5 seconds. And so we look once again at our graph. We can see that this is going up 4 and over 4. So the slope here, 4 over 4 equals 1. And so the net force is going to be, if 1 is our acceleration over this time period, right? Because 8.5 is going to happen right here. And so since this line is linear, it's linear, it's not all squiggly, we know that the acceleration is the same throughout this whole time period. And so we can take the average, and it'll be the same for each point within that line. So we plug that in, so force. So now instead of 0 equals 1, which equals 2.75 newtons. So I'll write it down here just to keep it all nice and clean. So that's it. So just as a little reminder, when you're dealing with a velocity versus time graph and dealing with force, remember to always look at the slope of your line. If you're dealing with an acceleration versus time graph, you would just look at what the acceleration is during that time. But in this problem, we were able to find the max net force. We were able to find when the force equals 0. And we were also able to find the force at a given point. I hope you learned something. Hope you enjoyed it. We'll see you next time.